the Eberline ESP-1. This is one of the early attempts to make a digital rate meter, one that has a microprocessor. I got my hands on this unit a while back. It was sold as for parts are not working, described as powering up but with a jumbled display. At the time I was looking for a project, so I made the investment. It proved to be a challenging project, eventually involving an Arduino, some CAD work, and even 3D printing. But now it's in working condition. Here I will show a teardown of this unit and discuss the repairs and modifications I made along the way. The bottom of the unit unscrews with one big screw. This is not as easy as the metal clasps that some rate meters have. I have done some preparation and now soldered the battery wires and high voltage wire. Normally they would be connected to the circuit board. The speaker wires would normally be soldered too, but I added a couple of pin headers to make disconnecting it easier. These ugly black bulges are a replacement of one of the ICs on the circuit board. I will show these in more detail shortly. We can now remove the screws holding down this bottom circuit board. The screws and hold are not really well suited for the board and barely make contact with it. This means that it sometimes can let go and fall down. This puts it in contact with the bottom, which happens to have a convenient conductive coating to act like a Faraday cage, presumably. The conductive coating shorts out everything that contacts it on the now dislocated board. This is not good. I added a row of pin headers to this ribbon connector. Before it was soldered in place on both boards, which made maintenance difficult. Let us take out the bottom board and take a closer look at it. I can remove my replacement ICs and then show the real IC that I replaced. This MC14575C is a dual op-amp, dual comparator. The ESP-1 had two of them to begin with. Ever since an incident where the board dropped and came in contact with the bottom of the unit, both stopped working properly. The symptoms I got were peculiar, and it took a while to troubleshoot it back to these two. The high voltage would start at power up, then decrease constantly. I replaced each MC14575C with one LM393AP comparator and one MCP6002 op-amp on a small separate board that connects with these pin headers. The black electrical tape is an attempt to prevent another short circuit if the screws were to slip off the board again. Now onto the second board. This board was created by me and does not look like this in a standard unit. This was the board that first populated the spot. And this is what it looked like when I first got it. The corrosion was not too difficult to clear off. Slightly more difficult was finding all the broken traces on the board. Eventually I just decided that the EPROM had gone bad or erased itself. Some guy on the internet says that the EPROM can't be trusted, and apparently neither can most other parts of the meter. This replacement board is based on an Arduino Nano. Thankfully, it was not especially difficult to use the Arduino. Most things could just be connected straight to it. Here's a schematic that I threw together that might help if you're trying to do what I did. It can be downloaded in the description below. The Arduino code I mostly wrote by myself, but some of it I borrowed from the DIY Geiger counter webpage. I have previously bought one of their Arduino-based Geiger counters, and it works great. That code can also be found in the description. I added a micro USB port to fit through the access panel on the side of the unit as an extension of the Arduino's mini USB port. Speaking of the access door, let us take a closer look at it now. As some of you can tell, this door is not the one that came with this ESP-1. The one that came with the meter was missing a part in the locking mechanism. This is what it is supposed to look like. I'm missing this black part. So I measured the door, made it in FreeCAD, made another part in FreeCAD, and then 3D printed them at my university. This one has a space for a nut, and this other one has a hole for a screw. These are M5 screws and nuts. You can check the description if you want the STL files for these two. These new parts fit like this and hold the door well in place. It takes a few more turns of this screw to get this door off compared to the ESP-1's original door lock. With the boards in the unit, this door grants you access to the Arduino's micro USB port as well as the ESP-1's adjustment potentiometers and switches. This is how you would plug it into a computer to program the Arduino. I also replaced the ESP-1's MHV connector with a BNC connector. I had to use two copper washers here to get the BNC connector to fit, as the MHV connector had been mounted from the inside with a nut on the outside. The only thing left in the unit is now the LCD display and the buttons. I believe it uses the Hitachi HD44780 LCD controller. The Arduino is easily compatible with these types of screens. I was lucky because if Hitachi had just been a few years late with their development of this LCD driver, Eberline might have gone a different route with the display. Remember that this unit is probably from the early 1980s. The buttons on the top of the unit are also here. They are these rubber or silicon contact buttons. They short out these traces on the PCB when you press them, which registers a button press. There is also a small lamp here to light up the display if you press a button. I was thinking of replacing it with an LCD in the future, as it's currently not very bright. Now I wanted to test the unit and show what my repairs can and cannot do. The menu looks different from what it should be on the ESP-1 because it's my Arduino program doing the displaying here. You can cycle through pages on the menu with the mode button. It has a detection rate screen with a running average for the CPM, a scaler or a time integrator mode that I have not yet programmed, a high voltage and threshold voltage readout display. The high voltage and threshold measurements also work decently, which you can see here as I adjust the corresponding potentiometers. Although the threshold voltage has a kind of low resolution. The high voltage measurement can be a little unstable at times too. And a battery voltage menu that I did not finish either. The speaker button works thanks to the Arduino. The light button also works, but this is not thanks to the Arduino. It is possible to add a few more things that I did not think of, as the Arduino still has a few unpopulated inputs. Plugging in this BGO simulation detector, the unit works as it should. The running average CPM may need some adjustment. As it is now, it takes 15 seconds for the running average to have caught up, so to say. The bar graph works well and can be readjusted with the reset button. The repairs that I made would not have been possible without the manual for the unit and the schematics of the unit. There's a copy of the ESP-1's manual in the description too. Well, I think that concludes this video. I hope that you found it interesting or maybe even helpful if you happen to have an ESP-1 that does not seem to want to cooperate.